Oh yeah, did something freaky happen?
Yeah, so I got, I did 2 and 3 and 1 and 2, and then I got to 4 and 5, and I just kind of got stuck, because if you multiply 4 by 2, it cancels everything out.
I'll have to catch up to you. So back in 9.1, this is where you don't use matrices. Cool. So tell me again, what was your first step on this?
So I did 2 and 3 first, but 1 and 2.
So 1 and 2?
And I canceled out the y.
Okay, cool.
So I got 6x plus 4z equals 5.
I like it.
And then I did 2 and 3, and I got 3x plus 2z equals 3.
So you add 2 and 3 together, okay?
Yes.
3x plus 2z equals 3. I like it.
And I just got stuck there.
Okay.
It was 12 o'clock, and I was just kind of like, I don't really want to deal with that right now.
So tell me what you did, though. You did something.
So I just kind of did a little bit of mental math, and I thought, well, what can I add, or what can I multiply by? And I just kept coming up with multiplying 4 by 2. But it cancels everything out.
Well, oh, you mean multiply
Yeah.
this one by 2, right?
Yes.
Yeah, sure. Of course.
Or I mean...
So multiply this one by -2, and you'll get -6x minus 4z equals -6. So when you add these together, what do you get?
It just cancels out.
So yeah, you get 0 equals
1, -1.
-1. I love it. And now I love that. You're acting like, well, it doesn't matter. Yeah, it does. These are not equal to each other ever.
Okay.
What does that mean then?
Oh, so there's no solution.
No solution.
Okay.
Yeah. It means those planes are like parallel to each other. They never hit. At least 2 of those planes. Maybe all 3 are just stacked on top of each other. Like, where do we meet? Nowhere. Shit.
Okay, so if that happens, it doesn't mean that I'm getting math wrong. It just means...
Not necessarily.
Yeah, I went back and I saw that it said if possible.
Yes,
So-
if possible. Exactly. Exactly. I like it. Cool. So yeah, don't assume you're wrong. Especially, I mean, 6x4, 3, 2. I mean, that's like in your face, kind of like they made it to come out that way.
Yeah.
Yeah. I like it.
Thank you.
Yes.
30 for 10.1.
Number 30.
Yeah.
Okay. Let's see. So is that one cool there? I mean, that's, what was that? That was number 32. So that's a one to expect freakiness from. What happened with number 30? That should come out nice. And you're like, well, that's nice. That's nice to know, Jeff. Hey, what's happening over here? It doesn't matter too much, but do you know something about row 2 there? Equation number 2? No? Yeah. I mean, you basically, whenever you see that, what's really awesome about that is, if I divide this by 2, it's going to cancel directly with that, right? Which is nice, but then that's kind of gross to deal with, right? So I don't even know if you want to deal with the x's. Z's look nice. You guys see that? So again, if you didn't see the division by 2, you could just do what with 1 to make those z's die here. Multiply 1 by 2. I like it. You guys cool with that? I mean, oh my God. I love you guys. I got to take some kind of a hyper-perceptive. Have you ever seen the show Psych? I need to be hyper-perceptive to pick one that's small. Because you guys hide things so well, man. Shit. I have no feelings about this. All right. So where did this thing go wrong?
I just feel like I keep adding stuff.
Oh, so sometimes you like pass yourself by because you kill a letter and then you go kill a different letter and then you'll never make them match up. Or something like that happens. So if right now I decide to kill these z's, I then have to kill the z's again. The same letter. So if I double this and kill those z's, I'll end up with an xy equation. I want to make another xy equation, so maybe I can use that and that. And kill those z's, I'll make another xy equation. It's really easy to kind of like miss yourself. You kill a z and then you kill a y, and then you're like, what the shit do I do with this? And I would be like, I don't know what you do with that. Don't do that. Kill the same letter twice. Okay, maybe. Okay.
Yeah, I think I just kept like trying to do all the letters.
Oh, shit. Yeah, don't do that. Yeah, it's basically always pick a letter, kill it twice. Right? If there's a hole, a letter's already been killed. Kill it one more time. Right? If that wasn't there, I'd kill the x, and then I'd have two yz equations, and I know what to do with that. I know what to do when there's only two variables. That's awesome. Okay. I think so, anyway. All right. Is that good enough, or okay? Anything else from homework stuff? Yeah. Oh, yeah. 19 is almost too nice to believe. It's got that last, is it 19? 18?
Yes.
Oh, 18's even, oh my gosh. Well, 18 they say use substitution to solve. Because notice in number 18, you already know that C is 3, right? So then you can plug it into the equation above it and figure out what B is.
You can fraction, like 2 over 5.
Let's see, 3, 6, 2, oh well. And then you plug that number in.
In the fraction became like bigger and bigger.
Yeah, totally, yeah. Yeah, we need to be able to handle fractions, and we can't be scared of them anymore. We created the damn things. So let's see. It tells us directly in the last line that C is 3, which is too good to believe. All right? So plug a 3 in there, you can solve for B. So sure enough, you get 6. You get negative 6, right? Add 6, you get 2. Yeah, so B is 2/5. So now I got to plug a 2/5 here and a 3 there and solve for A. So, I mean, don't second guess yourself. It's just going to be like denominators flying all over the place, right? Yeah. And if you really want to, I mean, so does everybody see how you get B is 2/5? You put that in there, you get minus 6. You add 6, you get 2, divided by 5, so B is 2/5. So now I can say 5A plus twice B minus 3 times C equals 10. Now this is an equation, right? So if I really am truly frightened of fractions, then what can I do? Which is really nice. What's the only fraction in here? Yeah, so I can multiply by 5. I heard somebody whisper it. I love you guys. Speak up. So if I multiply by 5, I can kill the fractions right off the bat, right? If you want to. It's an equation. I'm allowed to do that. I can multiply everything by 5, and then what happens? Both sides. So 5 times 5, 25A. 5, these 5's cancel. 2 times 2 is 4. 9 times 5 is 45. 5 times 10 is 50. Now solve for A. And then who cares? The fraction is going to show up at the end. Did you have to multiply by? No, you could actually make 4/5. You can work with a fraction, but if you don't want to, it's an equation. That's the one time you're allowed to kill them. Yeah.
I don't understand what 54 is asking for 9.2.
9.2?
Yeah.
Oh, all right. So they say inconsistent or dependent, right? And I'm not as concerned with the language. Inconsistent, what's your gut tell you? Inconsistent. If the system of equations is inconsistent, Like if I had two lines that are not consistent with each other, they probably never touch, right? So inconsistent would mean that there's no solution. And tell me, give me an example of solving a bunch of shit like we did earlier, and it ends up being no solution. What would your end result look like? Something like 0 equals -1, like we got earlier, right? What would that look like in a matrix? 0 equals -1. So we got x, y, z. So I want to say 0 equals -1. What would that look like in a matrix? How many x's on this side? How many x's?
0.
None of them. How many y's?
0.
None of them. How many z's?
0.
None of them. And what's the number?
-1.
There. So if you get zeros and -1, that's not going to possibly be true. How could I get -1 if I don't include any of my variables? None of these, none of these, none of these, and you end up with -1. How the hell do you do that? You got nothing. Now, what would dependent mean? What do you think dependent must? It must mean the other extreme. Say again? Yes, in fact, infinite solutions, right? And that would be related to 1 equals 1, or even better, 0 equals 0. You can always make it 0 equals 0, right? So what would that look like in a matrix? 0 equals 0 would be 0, 0, 0, 0. Now, how do you end up with a row like that? Now, think about it. If you add two rows together, what must be true about them if you end up with a row like that? So if one row was 2, -1, 4, 5, what would the other row have to look like so I add them together and end up with this? -2, 1, -4, -5. So this one has to be negative this one. Or it could be twice this one, because then when I take this times -2, they'll all cancel again, right? So one row would have to depend on the other row. It has to be twice it, 3 times it, negative times it, something times it. That's why they call it dependent if there's an infinite number of solutions.
So it does want us to like work out that problem.
Yes, work it out, and then if you get a row like this, that means it's inconsistent. They don't meet, there's no solution. If you get something like this, that means they're dependent. You get an infinite number of solutions. Yeah. Okay. I feel bad for you. What's going on? Are you guys all right?
Just don't write down a lot of words.
What's up?
You should write down some more like words like while you're doing the problem, like or like numbers, like steps. I can follow.
I did a whole handout.
Oh, you're
Right?
right.
Yes. It's crazy how I do that.
Oh
Yeah.
my God.
Yeah, I don't like to do this every damn time, so I do it once and then reference the steps. Yeah. But yeah, you're right. If I ever do something where I don't show you the process somewhere, call me out on that, for sure. Okay. There's also a lot of words in the book that's already been written down. So I know a lot. Trust me, man, I didn't read every book I ever got in college either. Shit. Right? But, at least look at the examples, because they'll do step-by-step stuff too. Okay. Is there anything else from homework stuff? All right. So, let me see. We're going to get into, remarkably enough, chapter 10, which talks about radicals. Well, the first couple sections should mostly, the first section especially, should be review. The second section might be brand new to some people. Of course, what's another name for radicals? Troublemakers. Yeah, roots, right? Square root is an example of a radical. Cube root, fourth root, any kind of root. Okay, I like it. Real quick, if I ask you this, what number squared is 9? What number squared gives you 9? 3. Or negative 3. I like it. So we do have two square roots. We have a positive root and a negative root. Right? So there are two. There's 3 and negative 3. So when I ask you what's the square root of 9, I'm specifically asking you for the positive root. If I wanted the negative root, I have to say what's the negative root of 9. So square roots are always going to be positive. We're not going to get into complex stuff yet. See, so square root of 9 is 3, but then I want the negative root, so I'll get negative 3. I like it. So this symbol is called the principal square root. It's the positive root. So one we consider right away. If I want the negative one, I've got to put a negative on it specifically to get the negative root. Okay, I like it. Maybe. Now what about just the basics here? Let's see. What would the square root of 121? What's that? 11. Good. So that wasn't maybe so basic. Hopefully you guys are going to know some of your times tables. So 11 times 11, 120. So why is it 11? Because either 11 squared is 121, or it takes two 11s. It takes two 11s. There's a 2 here. It's understood 2 here. It takes 2 of them to make 121. Okay. So how do you think you would do something like, what you got, Jeff? The cube root of, let's say, 343. What do you think you would do with that? Does anyone just know it? No. Some of you are trying to find your cube root, but I don't like it. But no, it's not allowed. We had a discussion about that. Your calculator passes and you stay. What would you start to do? Considering what's one way to do this, a root? 121 breaks down as 11 times 11. So then the answer is, what does it take 2 of to make 121? So that's really the question this symbol represents. So what question does this symbol represent? What question does this symbol represent? What does it take 3 of to multiply to be 343? So then what do I try to start doing? I try to start breaking this thing down. So what the hell would go into 343? Does 3 go into 343? No. I can see that very quickly. I think we had a discussion about this. 3 plus 4 plus 3 is 10, which is not divisible by 3. So 3 can't go into it. So that means that 6 can't do it. It's not even, so 2 can't go into it. 5 doesn't go into the damn thing. 4 doesn't go into it. It's not even. Where are we at? 2, 3, 4, 5, 6 doesn't work. So let me try 7. Or, you can divide by all those things and the calculator spits out crap. And you're like, okay, that didn't work. Yeah, 7 goes into 343 49 times. And of course 49 is 7 times 7. So what is the cube root of 343? 7. Because that's what it takes 3 of to make 343. God, that's the biggest reaction I've gotten out of you in a while. I'm very excited. I'll stop talking about it, so maybe I'll have to. Right? So we're going to study something later this semester called logarithms. Has anybody ever heard of logarithms? I love it. So I always get that reaction. And the biggest problem people have with them is they don't understand that it's understanding what the symbol is asking you. Why did we use this symbol? No reason, to be honest. We just picked one. And said, this symbol will mean this question. The question is, what does it take 3 of to make this? When we do logarithms, they picked a really bad symbol, L-O-G. It's a word. You're like, what do logs have to do? What the shit is this? But they chose that symbol, and we just have to say, what's the question that this asks me? So every time I see it, I translate it into an English question. So whenever you see a radical, you translate it into an English question. What does it take 2 of to make this? What does it take 3 of to multiply to be this? That's the question it's asking you. And once you realize what the question is, you can attack it. You have different, we start to break it down, or is it obvious? What? So what about this one? What about the 5th root of 243? Now, is it semi-obvious what number goes into 243? Yeah, 24 and 3. So 3 goes into that. 3 goes into 24. 3 goes into 3. And 81 is 9 times 9. And 9 is 3 times 1, 2, 3, 4, 5 3s. So what's the fifth root of 243? 3. So the answer to a radical is always, what does it take this many of to make this? So it's always cutting it down. A power builds something up. 3. Oh, it's just 1 3. To the 5th power. Holy shit. Now I gave it 4 more buddies. And it builds up. 5th root is the opposite of that, saying, what would I raise to the 5th power to make this? It cuts it back down. Oh, I'll chop you back down to 3. What will it do? Maybe. Okay. So that's the real basics of radicals. Here's a couple of slightly freakier questions, or maybe 4 or 5 of them. Here's the first one here. What's the square root of 0.04? The answer is not 0.02. You got to remember how decimals work when you multiply them. What's the square root of 4? 2. So it's got to be some kind of 2, right? There's something involved in 2 here. But what, for example, what's 0.2 times 0.2? Don't say 0.4, my God. Yeah, it's 4, and then you go once, twice back. Do you remember that? Once, twice back. So the square root of 0.04 is 0.2. So be careful if there's any questions about square roots or cube roots or whatever of decimals. Take a guess and then check it real quick. Make sure it comes out the right number of decimal spots when you multiply it. Don't just, cube root of 0.008 is 0.002. No. It's going to be way too small once you multiply it out. Maybe. Let's see, something else a little bit freaky, but it shouldn't be that bad. What's the cube root of negative 27 over 125? 11. I need the cube root of negative 27 over the cube root of 125. I like it. Radicals are basically on the same level in order operations as exponents, because as we'll learn in a minute, they are exponents. But at least you understand they're related to exponents, right? 3 to the 5th power, and this is the reverse of that. So they should be on the same level because they're opposites of each other. Right? So at the same level of order operations. So it's sort of like saying A over B squared. Well, what would that be? That would just be A squared over B squared. So that's really all we're doing here. That cube rooted is the cube root of 1 over the cube root of the other. We're just kind of distributing the root. Same way I would do with the power across the division. Now, what is the cube root of negative 27? The cube root of 125? Yeah, you should remember some of these numbers from difference of sum of cubes. And, of course, difference of sum of squares with the square roots. Oh, if it's reducible? Yeah, if it's reducible here, that means it should have been reducible here. So I would reduce this sucker if it's possible first, because then I got smaller numbers to worry about with the root. Okay, so fractions, don't let them be a problem. And then finally, what about this weirdness here? Let's do several of this one. What's the 5th root of x to the 5th power? Okay, that's one way to look at it. 11. So that's what ends up happening because they're opposites of each other, right? They're opposite operations, so they kill each other. Another way to look at this is, what does it take 5 of to make x to the 5th? Well, it takes 5 x's. The answer is staring me in the face. So what really does happen is this. They do cancel. 5 goes into 5 once. Now, see if you guys remember, we had a little talk about this before, but see who remembers. What's the square root of x squared? Nope. Huh? Nope. Because what could x be? X could be anything. So that means it could be positive or it could be negative. So again, the answer to a square root has to be... Nope. The answer to a square root has to be positive. It is this principal square root, the square root symbol. So it's got to be positive. So what covers our ass if sometimes it might be negative? What do we throw around it? Absolute value. So we had this discussion before. In fact, any even root might act like that. But again, basically the understood 2 there and the 2 there cancel. I just have to cover my ass in case the x is negative. When is it going to happen? Only when I have an even root. Odd roots are so cool. They're so laid back. They're like, oh yeah, you're negative? All right, you're negative. No big deal. Even roots, you put a negative, they freak out. You try to do them, they might need an absolute value just to make them feel safe, right? Maybe. So even roots really uptight. You got to make them feel safe. Put a little blanket around them. Odd roots, they're chill. They're laid back. Whatever. I could take negatives. Whatever.
What happens if you get a fifth root to x to the negative 3? How do you cancel this? How would you do that?
Well, you can't, right? Fifth root, and there's only 3 inside. So let's look at your question. If I had taken the negative out for a second, fifth root of x cubed. Why? Tell me why I can't do anything. What does the fifth root need inside of it to be able to be done? 5 of something. 5 of something, right? Just like this one had 5 3s, that's why I could do it. If I would have put 81 in there, it would have only been 4 3s. Too bad for me. I couldn't do it. I couldn't simplify it, right? That's with me? So this one, you really can't do anything with it. In the next section, we'll learn a different way you can write that, but it's just a different way to write the same idea. You can't really reduce it or simplify it. There's not enough stuff on the inside, right? I need 2 more x's in there to be able to do something, at least. But what's this? Kind of in the same vein. What is the fifth root of x to the 10th? Yeah, what does it take 5 of to make x to the 10th? Well, it takes 5x squares, right? What's the shortcut here? This is too good to believe. This is kind of bleeding into the next section. 5 goes into 10 twice. That's what it takes. What does it take 5 of to make 10 x's? Well, it takes 5 groups of 2. Isn't that division? That's the definition of division. And think about it. If roots are the opposite of exponents, and when I raise a power to a power, I multiply, then when I do a power to a root, I must divide. They're opposites of each other. That's so beautiful. You got to let that be. It's just true. Yes?
Why is it like the absolute value?
Oh, so again, what's the square root of negative 4 squared? Negative 4 squared is? Negative 4 squared is 16. And what's the square root of 16? 4. So is the square root of negative 4 squared equal to negative 4? Is the square root of x squared equal to x? Always. Well, no, if x is negative 4, what's it actually equal to? Is it equal to negative 4? No, it's equal to the absolute value of negative 4. The outcome of a square root, of an even root, must be a positive number. It's understood to be the even, the positive root. So you put an absolute value around it just in case the x itself is actually negative. So you can't say this. This is not true if x is negative 4. It's not true. If x is negative 4, is the answer negative 4? No. The answer is the absolute value of that. Right?
But you wouldn't do that for...
Totally not. Exactly. And again, it's all because of this. What's negative? Again, what's negative 4 times negative 4?
16.
Positive 16. What's negative 4 times negative 4 times negative 4? Negative 64. So if I have 2 of anything, or 4 of anything, or 6 of anything, and they're all negative, they're all going to pair up and die. The answer is always going to be positive. I kind of lose information about what they were. But if I have an odd number of things, and they're all negative, they'll pair up and there'll always be one dude left over negative. The answer will match what it was to begin with. That's why roots can work backwards. And odd roots can work backwards. Even roots are like, shit, I don't know.
So if it was the sixth root of x to the 12th, would that be the absolute value of x squared?
Here we go. You ready? I love that question. So again, now that hopefully we understand the shortcut here. This is a beautiful shortcut. 5 goes into 10 twice. 6 goes into 12 twice. Now, it is a sixth root. So it is one you have to be careful about. If the answer could be negative, you do have to put in absolute values. But x squared is only ever positive for the real numbers that we're talking about, right? So if you put an absolute value there, I'm not going to take points off. I'm going to say overkill or something. Does everybody get what's happening? Why do I not have to put an absolute value here? Because x squared will never be negative. I don't have to save it from that. Whereas over here, x could be negative. Holy shit, I better save that. Maybe. Okay.
Is it okay to think that like square root, the principal square root is always asking the plus or minus square root of whatever is inside? No.
Nope.
Why is that?
Because it isn't. It's always positive. The answer is always positive. If you want the negative root, you actually have to put a negative sign on it. You have to be very direct. So absolute value doesn't mean plus or minus, does it? Absolute value means always positive. Yeah. Yeah.
So if you have a negative 5 to the x to the 20, like 5's on the outside. Negative 5.
Oh, a negative
Yeah.
here? We don't do negative roots.
Okay.
Can you? Sure. Can you do a lot of weird shit that we don't do? Of course you can.
So that's not,
We're not going to do that.
Okay.
Yeah, we're going to stop at the square root, to be honest. There are further roots, and in fact, in the next section, we'll see a better way to write them. But for example, would the first root make any damn sense?
No.
No, thank you. First root would make, so we basically stop at the second root.
Okay.
We don't go any further. Zeroth root would make even less sense, right? So negative roots, what the hell would they mean? Can you investigate them? Yes. Is it beyond what we're going to do here? Yes. But I love the question. Yeah.
What if we have 4 instead of 6?
All right, let's see. I love you guys. Here we go. 4.
Yeah. Then x
X12?
12, yeah.
Oh, look at that. Oh, that's awesome. Okay. That's where I was going to go. Maybe not those numbers, but it's beautiful. You got going. It's an even root, right? So the answer has to be positive. We didn't put absolute value here because the answer is positive, right? Always. So 4 goes into 12.
3.
Could that be negative?
Yes.
Yes. Oh, shit. Why? Because it's an even root. The answer's got to be positive. We have to cover our ass if it might be negative. Do I know for sure this is negative? No, because I don't know what x is. But if it's not negative, does this mess it up? No. It leaves it alone. So it doesn't really shake the boat. It just in case. Maybe. Even roots, very uptight. Oh shit, they're the ones that require, we can't put negatives inside or they don't become real. Or we better put absolute value around the answer because it's going to freak out. That's even roots. Odd roots, so laid back. No problem. I don't know if you guys remember, the domain of an odd root is all real numbers unless there's something freaky inside. I don't know if you remember that. Okay. Blah, blah, blah. Let's see what other freakiness. Oh, let's go further with this freakiness here. All right, don't overthink this. What's the cube root of y plus 2 cubed? Yeah, y plus 2. It's an odd root. Doesn't need any help. Doesn't need any security blanket. Right? Never called it that before today. But I like that. Now I'm going to use it. Bless you. Bless you. Right? It's an odd root. It's able to handle anything. It's very relaxed. Whatever the hell you are, I'm going to leave you alone. Now, if I had this, the fourth root of x minus 5 to the fourth power. Yes. absolute value of x minus 5 because it's an even root. I got to be careful in case x makes that thing negative. That's enough of that. So hopefully you guys realize even roots, you got to be careful. Odd roots, not so much. That's basically the takeaway from that. Let's see what other freakiness we get into in here. Don't do that yet. No, good. And of course, they're going to do some stuff like what I just said. They're going to do some function stuff, like you're going to be f of x equals the cube root of 1 minus 2x squared, and then give you some stuff to throw in there. Right? Good old function stuff. So it's one step away from the questions you were doing earlier. You put a number in, you get a number, and then you figure out what the cube root is. Okay. They're going to ask you domain. What's the domain of this? Say again?
All the x values?
All real numbers, right? So the domain would be negative infinity to infinity. Why? Because he said so. No. Then you agree. Sure, but no. Why? Why is that true? Because it is a, or an, yeah. It's a cube root. It's an odd root. It can handle negatives. So what's the domain of g of x equal to the fourth root of 5 minus 2x? What's the domain of this one? Oh shit, I don't know who remembers. No? Because this is minus twice x, there are going to be a lot of negatives that are going to work. There's only going to be a few positives that work, to be honest. So again, we said this before. If I ask you for the domain of something, you say in English what must happen. So in English, what's got to happen for a fourth root? The inside has to be... No. So in order for an answer to exist, is everybody cool with, let me make sure, based on that question, I'm a little concerned. Square root of 16 is what? 4. What's the square root of 14? I don't know. Right? It's 3 point something. Is that cool? It's right below 16. It's right above 9. So it's going to be between 3 and 4. Is it an answer? Is there an answer for it? Yes. Is it nice and pretty? No. It's 3.79248 and whatever the hell. It just goes forever. You guys with me? So sure, I'm going to give you questions like this so you can do them without a calculator and you can show me, that you know how to do this shit. This sucker we need a calculator shop, but it still works. It still exists. It's still a real answer. So what I'm asking you right now is, how do I make sure I get a real answer out of this? Not a nice answer, a real answer. Well, what's the smallest number I could do a fourth root of? What kind of number can't I put inside of a fourth root? Negative. I can't put a negative number. So what kind of number must it be? The inside, you're going to love this, not just positive. What's the opposite of negative? I love it. You guys are like, positive? What the shit? Or 0. Don't forget poor little 0 dude. 0 dude is the one that's like, I'm both. Don't judge, right? 0 is like, I'm negative and positive. That's nice for you. So the opposite of negative. So the inside has to be at least 0. How do you write that in mathish? So remember what I said. If they ask you for domain, say it in English, what must be true, and then write it exactly what you just said, write it in mathish. So what's the inside? What's the inside? 5 minus 2x. Okay. At least 0. How do I write that in mathish? No. At least 0. At least 0. Greater than equal to. At least is more than, at most is less than. Yeah. And then solve that, right? So I would add 2x divided by 2. I get x less than or equal to 5 halves. So there are a few positive ones, but mostly it's all the negative ones that work. I say a few positives, there's actually an infinite number of them, but this would be the domain right there. Bam! And again, people don't believe that. If you say it in English, what must happen? Translate what you just said in mathish. You've just written a restriction. If I solve it, it's a restriction on x. This is the restriction on the inside. This is what it looks like, the restriction on the inside written in Mathish. If I solve it, I see what must be true about x to make sure that this is true. X has to be at most 5 halves.
So it's all numbers less than 5 halves, up to 5 halves?
Yeah, exactly. Yeah. Because what do I get when I put a 0 in there? 4 through to 5, 11, which is something, right? It's something. It doesn't not exist. It is something, just nothing nice. If I put a negative 100 in there, don't I get 5 plus 200? And the 4 through to 205 is a number. I don't know what it is, right? As long as the inside is not negative, and that's why this is true, because I'm subtracting this. So if x is negative, it's automatically good. And there's a few positives that work also. Okay, oh man, you guys really love this stuff. I think. I don't know. See, I didn't even get anything from that. Normally I at least get a reaction to the follow-up. Okay, all right.
I know you just solved it, but I don't know, because I know it's not right, but I was going to say like 4th root of 5 minus 4th root of 2x.
Oh my God. Oh, I didn't mean to react like that. Because roots are relatively new, but again, they're just like exponents.
Break them up, can't you?
All right. How would you do this? No. How would you do that? Come on. Yes, and then FOIL, right? Which FOIL, I hate FOIL. I don't know, have you had this discussion already about FOIL? Okay. Some of you guys are like, we know your opinion about FOIL, whatever, man. You can wrap your potatoes in something else. Shit. Stupid FOIL joke, sorry. But FOIL was stupid. It really is. I'm sorry. It just is. Why make it seem like you need this whole thing to remember? Oh, it's so hard. You need letters. No. It's just repeated. What you got to remember is to write this thing twice. Can you just do this and make it a squared plus b squared? Oh, hell no, right? Why doesn't that work? Because exponents are not based on addition. They're not going to distribute. Roots are not based on subtraction and addition. They're not going to distribute. I like it. Good. Beautiful. Because I have people in my Calculus 3 class, right, last semester, that was telling me, square root of x squared minus 9 is x minus 3, and that's the quickest way to make your calculus teacher cry is to do that. Now, if you guys do that, I might tear up, and maybe no tears come out. But you guys understand now why that so is not true. It can't distribute across a minus sign because it's not based on addition subtraction. It's based on multiplication. Yeah.
So if the root was and underneath the root was a multiplier, you would split.
Yeah, totally. So if I add, what's the square root of 9x to the 4th? Square root of 9 is 3. Square root of x to the 4th is? Do I need absolute values? It is an even root, but the answer is always positive or 0, so I don't need absolute value. I love it. Beautiful. Roots are the same place as exponents. They are based on multiplication. Therefore, if I have a multiplying thing, a product inside, it can distribute all day long. Totally. So if I had AB squared instead of A plus B squared, well, what's AB squared? What's that? A squared B squared. It distributes because exponents are based on multiplication. Of course they're going to work nice together. I really want you guys to understand that. I never hear anybody explain it like that, and I'm like, that is why it works that way. If you have an operation based on what's going on, easy. If this operation is not based on this, shit, I need some other way to work around it. Or I just can't do it, right? So you can't simplify this in any way because it's a minus. I like it. Okay. What else is in here? Oh, let's try this out. I think you guys are ready for this now. Let's give you one that's not too freaky. That's just a square root of x by 2. So I want you to find the domain. And then graph by making an XY table. Try it out. Now there must be a reason this question will help you with this question. Let's see if you see why. If you don't, it's okay, we'll talk about it, and then you go, oh shit, and then you'll do it forever from now on. Who cares? So let's see if you get it by yourself here. Is this somebody's pool? Some names in there. Just a syllabus and some chewed up paper. A low on fiber. Here's an example where you can be smart about the numbers you use in your table. I don't want to graph 1.759223. I don't want to graph that shit. I want to plug numbers in so the answers are nice. I can plot those then. Let me see, just make sure you got the first step right, because if you don't get the first step right, your second step might get all freaky on you. How do you find the domain of this? What do you do? Solve what? What must be true about the inside? Greater than or equal to. It has to be at least 0. I like it. Right? That's what must be true. Why? Because it's an even root. Even roots are the uptight ones. Oh, shit. That's got to be greater equal to 0. Therefore, x has to be greater equal to 2. So it's a really smart number to start with in your table. 2, it's crazy, because that's the smallest number I can use, and then go up from there. Maybe don't use 4, because the square root of 4 minus 2 square root of 2 is kind of gross. Not the grossest thing ever, but it's not a whole number. That'd be even better. So be smart. Use 2 to start with, and then be smart about what else you plug in. Do at least like 3 inputs. Of course, when you plug a 2 in, what do you get?
0.
Great. Next good number to use? No. 3. 6 is a good one. We'll still choose that one. The next good one is 3. 3 minus 2 is 1. Square root of 1 is crazy. 6 is the next good one because it ends up with a 4 on the inside, and that's the next square rootable number. So do you see what I mean about being smart about what you plug in? So square root of 4 is 2. Crazy. So 2 is at 0. 3 it's at 1. And 6 it's at 2. Blah. So it does sort of look like, you see if I put like a little mirror image, it looks like half a parabola fell over and this part just fell out. Right? Do you see that? Because the square root is related to a square. They are opposites of each other. Why is it missing the bottom part? Because the output can't be negative. That would be the negative root. This is the principal root. This would be the negative root, that missing other piece of the parabola. Just said a lot of shit, but hopefully you guys get that. So any even root is going to have that shape. Why is this start at 2? Because I had an x minus 2 in there. So all my inputs have to be 2 bigger so that when I subtract 2, it's still doable. So if I had a plus 1, it would have actually started at negative 1. That's why this step is important. Right? What's your domain so you know where to start? Okay. So, following up on the heels of that one, do the same thing with this. Sure.
I don't
Yeah.
know what you said about skipping the 4 and chose 6.
Well, if you use 4, you get the square root of 2, which is a number. You could do it in the calculator, 1.414, blah, 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 blah. Not the easiest thing to really graph well, right? So I'm just saying, you want to pick things so that the answers come out whole numbers. You're going to connect all the dots anyway. You just want nice dots, nice anchor points. Yeah. Here, the domain doesn't really help you out too much, right? But you just start using smart numbers, negatives and positives, just to get both sides of things. Because what's the domain going to be?
It's all real.
All real numbers. Why? 2 reasons. Because the root is odd, and the inside has no problems. Inside's just x plus 1. I can add 1 to anything. If this would have been the cube root,